All right, so this is chapter 1 of statistics, and the first section is 1.1, which is an overview of statistics, okay? So, the first thing obviously is what is statistics? It says statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So, we frequently see statistical tools such as bar charts, tables, plots of data, averages, and percentages on TV and in newspapers and in magazines. Such methods used to organize and summarize data so as to increase the understanding of the data are called descriptive statistics. Statistics is also used in practice in many different walks of life, going beyond simple data summarization to answer a wide variety of questions, such as in medicine, does a certain new drug prolong life for AIDS sufferers? Science, is global warming really happening? Yes, it is. Education, are GCSE and A level examination standards declining? Psychology, is the national lottery making us a nation of compulsive gamblers? Sociology, is there a gap between rich and poor widening in Britain? Business, do Persil adverts really make us want to buy Persil? Finance, what will interest rates be in 6 months' time? So, when we talk about stats, one of the things we talk about is data. So it says data consists of information coming from observations, counts, measurements, or responses. Okay, so the next part we have here, guys, this is going to be a really critical definition because we're going to be talking about these two things throughout the entire semester of the course, okay? So it says a population is a collection of all the outcomes, responses, measurements, or counts that are of interest, and a sample is a subset or part of a population. Okay, so the population refers to all the outcomes, the entire population, the entire group, and a sample is just going to be part of that, okay? So here's the first example. It says in a survey of 834 employees in the United States, were asked whether they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Include the population and the sample and describe the sample data set. Okay, so let's talk about this one. Okay, so it says in a survey, 834 employees in the United States were asked whether they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population sample, describe the sample data set. Okay, so first let's talk about the population, and then we will refer to the sample. Okay, so a lot of times we want to think that the 834 employees is going to be our population. That's not actually the case. The case is going to be all U.S. employees, okay? The sample would be the 834 that they surveyed, right? So they're trying to get some information about all the employees, and what they do is they survey 834 of them. That's going to be my sample, okay? That's going to be my sample. So the 517 said yes. That's just, they're answering the question, but the people that were surveyed was the 834, okay? All right. Same thing for the next one here. It says in a survey of 1,501 9th to 12th graders in the United States, 1,215 said leaders today are more concerned with their own agenda than with achieving the overall goals of the organization that they serve. Identify the population and the sample and describe the sample data set. Okay, so again, we're going to talk about population and we're going to talk about sample. Okay, so look what they're surveying. They're surveying, 9th to 12th graders in the United States. Okay, so that's going to be my population. 9th to 12th graders in the U.S., okay? The sample is the 1,501 students that they surveyed, Okay. All right. Okay. So going along with those same ideas, we have something called a parameter and we have something called a statistic. A parameter is a numerical description of a population characteristic, and a statistic is a numerical description of a sample characteristic. Okay. So let's take a look here. It says determine whether each number represents a population parameter or a sample statistics. Okay, explain your reasoning. So number one says a survey of several hundred collegiate student athletes in the United States found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours a week. Okay, so look what they did. They surveyed several hundred college student athletes. Did they survey all of them? No, they surveyed a sample of them, right? So for number one, because we're dealing with a sample, what we then have is we have a statistic. Okay. So now take a look at number two. Number two says the freshman class at a university has an average SAT math score of 514. Which class? The freshman class. Part of the freshman class? No, the entire freshman class. Since they're talking about the entire freshman class, they're talking about population. They're talking about the entire freshman class. So because they're referring to the population, this is a parameter, okay? So guys, one of the easy ways to kind of figure this out, sample statistic, population parameter, okay? Now, number three says, in a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Okay, did they survey all the retail stores? No. They did survey several hundred of them, though. So again, this is a sample, which means this is going to be a statistic, okay? All right. Okay, here's another one, similar. Determine whether each number represents a population parameter or a sample statistic. Explain your reasoning. Okay, so part A. Last year, a small company spent a total of $5,150,694 on employee salaries. Okay, so did they spend that money on some of the employees? No, it says that they spent them on the employee salaries. So we assume that it's for all of them, right? So since it's all, this means we're talking about a population, so we're referring to a parameter. Okay. Part B says, in the United States, a survey of a few thousand adults with hearing loss found that 43% have difficulty remembering conversations. Did they survey everybody? No, they only surveyed a few thousand. So they surveyed a sample, which again means that we have a statistic. Okay. Okay, so the next part here is descriptive statistics and inferential statistics, okay? So let's go through this part here. It says descriptive statistics is a branch of statistics that involves the organization, summarization, and display of data. Okay, so there should be some organizing, summarizing, and showing or displaying data. Okay, inferential statistics is the branch of statistics that involves using a sample to draw conclusions about a population. Okay, so we're going to draw conclusions about a population. Inferential means we're going to infer. What can you gather from this, okay? So let's take a look at the first example here, example number 3. And it says, for each study, identify the population and sample, then determine what part of the study represents the descriptive branch of statistics. What conclusions might be drawn from the study using inferential statistics? Okay, so let's take a look at number 1. So the first thing is we're going to identify the population and the sample. Okay, a study of 2,560 U.S. adults found that of adults not using the internet, 23% are from households earning less than 30,000 annually. Okay, so what are we talking about? Population would be adults not using the internet. Okay, so my sample would be, how many did they sample? 2,560 that are not using the internet, right? Okay. Now, my descriptive stats would be the part where it says 23% are from households earning less than 30,000, right? Not only would that be my descriptive, so would the chart, okay? Then what we're going to say now is, what about the inferential part? Okay, so what can we conclude from this, right? So we have people who don't use the internet, right? These are adults who don't use the internet, and we found that 23% come from households who earn less than $30,000 annually, right? So if you notice, look at those percentages and look at those incomes. When you have an income of $75,000 or more per year, then you only have 3% of the people who don't use the internet, right? Or if you have an income of $50,000 to $74,099, you only have 6%, right? So what can we infer? Well, if we have less income, then it makes maybe the internet less affordable, right? Less accessible. Because those people who are earning less than 30,000, they need to spend their money on rent, utilities, groceries, that kind of stuff, right? They don't have enough money at the end of the month to say, hey, let me go ahead and get internet service as well, okay? Again, that's just a possible inference, right? That's just one that we have there. So now let's do the same thing for number 2. So let me get my pen ready. Number 2. Okay. A study of 300 Wall Street analysts found the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. Okay, so who are they talking about? Wall Street analysts. That's going to be my population. Okay, and I should say all Wall Street analysts, right? Because that's going to be the key word in population. Okay. Now, my sample is going to be the 300 that they surveyed, right? Or that they studied, okay? Then we're going to have our descriptive stats. Okay. The descriptive stat says 44% incorrectly forecasted high-tech earnings. Okay. So think about it this way. These are Wall Street analysts, right? They took 300 of Wall Street analysts. Out of those 300, 44% of them guessed incorrectly, right? I mean, that's a lot. 44% is quite a bit. So what could we infer? Let me get my pen here. My inferential, that stock market is difficult to predict, right? Why? Because you have these Wall Street analysts, and you took 300 of them, and even then, 44%, almost half, guessed wrong, right? Okay, so let's try one more like this. Same kind of problem. Part A. Okay, let's see. So part A says identify the population of the sample. Well, let's read the problem. A study of 1,000 U.S. adults found that when they have a question about their medication, 3 out of 4 adults will consult their physician, and only 8% visit a medication-specific website. Okay, so population, again, all U.S. adults, right? Okay. And the sample is going to be the 1,000 that were studied. Okay. Part B, the descriptive statistics, okay? So 3/4 go to the doc, and 8% go online, right? And then see what conclusions can we do, right? Well, it seems like most people trust their doc, right? 3/4. So guys, 3/4 is 75%, right? Like think about out of 4 quarters, if you got 3, you got 75 cents. So 75% of the people are going to go to the doctor. Only 8% of them are going to go online, right? So most people, apparently they trust their doctor, right? Let me go see what the doctor's going to say. They're not going to go to like, WebMD and try to diagnose themselves, right? Which you probably should not do anyway. Okay, you're really sick, go see the doctor. All right, so the next part here in chapter 1 is 1.2, which is data classification. So we're going to talk about classifying data now, okay? So we have 2 types of data that we're going to refer to. One of them is qualitative data, and this consists of attributes, labels, or non-numerical entries. And then we're going to have quantitative data, which is numbers that are measurements or counts, okay? So qualitative data, a lot of times, guys, are going to be like names too, okay? All right. So now let's see if we can do the first problem here, and it says classifying data by type. The table shows sports-related head injuries treated in the U.S. emergency rooms during a recent 5-year span for several sports. Which data are qualitative and which data is quantitative, okay? So qualitative, right? Remember what qualitative? Attributes, labels, non-numerical entries, names. Well, look at these. These are all the names of the different sports, right? They're the labels, right? We have the sport labeled basketball, baseball, so on and so forth, okay? So the qualitative is going to be the sports, right? And then quantitative, look what quantitative, numbers that are measurements or counts. Look what they're talking about. The number of head injuries, right? Those are measurements. Those are counts. They've counted how many individuals have suffered head injuries for these particular sports. So the number of head injuries. Okay, so let's try another one here. Same thing. We're going to figure out which is qualitative and which is quantitative. Okay, so let's go this way. Qualitative. Okay, remember qualitative are labels, names. Well, the different cities, right? The cities are going to be that. The quantitative, so think of the word quantity, right? How much? The population. Okay. All right. Now, we have something called nominal level of measurement. Look what it says about nominal level. Nominal are qualitative, right? Qualitative. So nominal level of measurement is going to be qualitative. It says data at this level are organized using names, labels, or qualities. No mathematical computations can be made at this level. And then we have ordinal level. Ordinal level can be qualitative or it can actually be quantitative, okay? Data at this level can be arranged in order or ranked, but differences are not meaningful, okay? So let's take a look. It says for each data set, determine whether the data is at the nominal level or at the ordinal level, okay? So here we have the top 5 U.S. occupations with the most job growth. Okay, so these are the top 5. They've been ranked, right? Because they have been ranked, number 1, this is going to be ordinal, okay? All right. Now, number 2, we have movie genres, action, adventure, comedy, drama, horror, okay? Are these ranked? They're not ranked or anything, right? Because they're not ranked, they're going to be nominal. Okay. All right. For each data set, determine whether the data are at the nominal level or at the ordinal level. Okay, the final standings for the Pacific Division of the National Basketball Association. Okay, so the final standings. So that means they're going to rank for the top, I don't know why I said, I don't know why I was thinking top 5. Okay, so we're going to have the first basketball team, right? The second, who got 3rd place, who got 4th place, so on and so forth. This is going to be ordinal, right? Number 2, a collection of phone numbers. 956-381-4711. 956-682-1112. 956, right? I'm going to keep playing this game. It wouldn't make sense for me to order them or anything. I really couldn't put them in any kind of an order, right? So these are just going to be nominal, right? Think about it this way. Most of us probably don't know a whole lot of phone numbers off the top of our head because we have them on our cell phones, right? So even though these are phone numbers, you know, you're going to have, like, your first one here is probably going to be your boo, right? Maybe your second one is your mom or your dad, that kind of thing, right? Those are just names, right? Yes, I said your boo. All right. So the next one here is data collection. Okay. So data collection, we're going to design a statistical study. So we're going to identify the variables of interest, the focus, and the population of the study. We're going to develop a detailed plan for collecting the data. If you use a sample, make sure the sample is representative of the population. We're going to collect the data. We're going to describe the data using descriptive statistics techniques. We're going to interpret the data and make decisions about the population using inferential statistics, and we're going to identify any possible errors. Okay, so let's talk a little bit about these things first. So a statistical study can be usually categorized as an observational study or an experiment. In an observational study, a researcher does not influence the responses. In an experiment, a researcher deliberately applies a treatment before applying the responses. So here's a brief summary. In an observational study, a researcher observes, measures characteristics of interest as part of a population, but does not change existing conditions. For instance, an observational study was conducted in which researchers were measured the amount of time people spent doing various activities such as paid work, childcare, socializing. Okay? In an experiment, a treatment is applied to a part of the population called a treatment group. Responses are observed. Another part of the population may be used as a control group in which no treatment is applied. The subjects in both groups are called experimental units. In many cases, subjects within the control group are given, a placebo, which is a harmless fake treatment that is made to look like the real treatment. The responses of both groups can be compared and studied. In most cases, it's a good idea to use the same number of subjects for each group. For instance, an experiment was performed in which overweight subjects in a treatment group were given the artificial sweetener sucralose to drink while the control group drank water. After performing a glucose test, researchers concluded that sucralose affects the glycemic and insulin responses in overweight people who do not normally consume artificial sweeteners. Okay, so in a treatment, guys, a lot of times we have a placebo, we have a control group, we have a treatment group, okay? So a lot of times this boils down to ethics, okay? So observational study, okay? An observational study could be something like if you have women who are pregnant. We all know that smoking is not good for you. And if you're a woman who's pregnant, they usually tell you if you're smoking, you need to stop. Right? It's going to be the best for your health, and it's going to be the best for the health of your unborn child. There are women who continue to smoke, right? And so they want to figure out, how does this affect the mother's health, and how does this affect the child's health when it's born, or if it isn't born, how much of this was due to the smoking. That's an observational study. They look for women who continue to smoke, and they study them, right? They run blood tests. They do these things so they can study what's happening. But you cannot ask a woman, "Oh, you're pregnant, would you do me a favor and start smoking cigarettes?" You can't do that, right? It's unethical. You can't ask people, "Hey, you just got a new car, do me a favor, drive but don't wear your seatbelt." But there's people who choose to drive and don't wear a seatbelt. And when there's accidents, they study that and they see what happens when you don't wear one, right? Experiments, again, have these control groups, treatment groups. Often there's a placebo that's involved, okay? So like they did the example here with the people who were overweight, and they said, well, let's see what happens when we give them an artificial sweetener, right? But you can volunteer for these things. You can, they do random drug trials. These are experiments, right? Okay. So, number one. The question here says, determine whether each study is an observational study or an experiment. Researchers studied the effect of vitamin D3 supplementation among patients with antibody deficiency or frequent respiratory tract infections. To perform the study, 70 patients received 4,000 international units of vitamin D3 daily for a year. Another group of 70 patients receive a placebo. This is an experiment. Okay. To conduct a study to determine how confident U.S. or Americans are in the U.S. economy, to perform the study, researchers called 3,040 U.S. adults and asked them to rate current U.S. economic conditions and whether the economy is getting better or worse. This is an observation. They haven't done anything. They just asked you a couple of questions, right? That's an observation. Okay. All right. The Pennsylvania Game Commission conducted a study to count the number of elk in Pennsylvania. The commission captured and released 636 elk, which included 350 adult cows, 125 calves, branch bulls, and 51 spikes. Is this an observational study or experiment? This would be an observational study, right? They didn't do anything. All they did is they caught some elk, they labeled them, categorized them, let them go. But nobody did any, there was no like treatments applied or anything, right? Okay. All right. So we have something called sampling techniques, okay? So let's talk about sampling techniques. All right. So we have here something called a stratified sample. And it says, when it's important for the sample to have members from each segment of the population, you should use a stratified sample. Depending on how you focus on the focus of the study, members of this population are divided into two or more subsets called strata. They share similar characteristics such as age, gender, ethnicity, even political preference. A sample is then randomly selected from each of the strata. Using a stratified sample ensures that each segment of the population is representative. Okay. So let's think about it this way. We live, most of us, I would say, live in the Rio Grande Valley. Let me get my pen going. Sometimes my pen freezes up. There we go. Okay. So we start saying, look, let's group people by city. McAllen, Mission, La Jolla, Sullivan, right? Sullivan City, Rio Grande City, right? Roma, okay. Edinburgh, right? I'm just kind of labeling the cities here, right? I'm not going to go too far. Far. You see what I'm doing, right? Okay. And then what we do is we pick a few people from here, 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 right? We're going to go all the way to South Padre, guys, right? We're going to try to get the whole valley, right? Willacy County, we're going to get you too, okay? Don't you worry. But we're going to pick people from every city in the valley, every region, right? This is what we call a stratified sample, okay? So we've grouped you in these we put you in these groups based on the city that you live in, and then we take people from each one, okay? Now, there's something called a cluster sample. And it says when a population falls naturally into occurring subgroups, each having similar characteristics, a cluster sample may be the most appropriate. So it says to select a cluster sample, divide the population into groups or clustered. Okay, we're going to do the same thing. We're going to go McAllen, right? Mission, La Jolla, okay, La Villa, Ed Couch, Elsa, La Máquina Amarilla, right? Everybody through here, right? Brownsville. Can't even spell today, right? Everybody. Okay. What we do now is we select the members in one or more, but not all of the clusters. So the difference between the stratified and the clustered is here we were taking a little bit from each one. A little bit of people from Sullivan, a little bit of people from Roma, a little bit of people from Edinburgh, a little bit of people from Far, that kind of thing, okay? In the cluster, what we do is we say, we're going to take everybody from La Jolla and everybody from La Villa and everybody from Brownsville, but we're not going to take all the cities. So we'll sample everybody in La Jolla, we'll sample everybody in La Villa, we'll survey everybody in Brownsville, but we're going to leave certain cities out, okay? That's the difference. That's how we kind of distinguish between those two, okay? Systematic sample. It says, a systematic sample is a sample in which each member of the population is assigned a number. The members of the population are ordered in some way, starting at a number that's randomly selected, and then the sample members are selected at regular intervals from the starting number. For instance, every third, fifth, or 100th member is selected, okay? That's how we do systematic, okay? And then there's something called a convenience sample. A convenience sample says, consists only of members in the population that are easy to get, okay? Easy to get them, all right? So think about that. It's easy to get. Now I'm going to answer the questions here, and I'm actually going to start with number 3. You select students who are in your biology class. Okay, so what does this mean? It means that number 1, we assume you're taking a biology class, and you got to do a survey. Well, hey, you're already there. All these people are already there. This is going to be a convenience sample, okay? All right. Okay, so number 1, you divide the student population with respect to majors and randomly select and question some of the students in each major. Okay, this is going to be, stratified, right? We're putting people in groups and we're taking some people from each of those groups, right? Okay, and then you assign each student a number and generate random numbers. You then question each student whose number is randomly selected, okay? Because we're going to get each student, this is going to be clustered, right? Everybody who has the number 3, we're going to ask you this question, right? Okay, so again, we're still going to do the same thing here. You select a class at random and then question each student in the class. So we have a whole bunch of classes at STC, right? And then we're going to take everybody who's in English 1301 V02. And we're going to take everybody that's in Math 1442 V01. Because we're taking all the students, right? All the students then this is going to be clustered. Okay. You assign each student a number, and after choosing a starting number, you question every 25th student. This here would be systematic.